Welcome everyone to Microsoft Ignite. Those who are joining us online, hi. Welcome to our developer session of how Visual Studio build Visual Studio with Visual Studio. I'm Fatima Ijaz. I am the Group Engineering Manager for Visual Studio Engineering team. I have been working with Microsoft for almost 10 years. Mostly my background is in cloud and services. I have experience of working in Azure, Bing team, and welcome here. Mark?
Hi, my name's Mark Osborne. I'm a principal software engineer in the Visual Studio engineering team, and I've been working on improving the engineering system for our developers for about 15 years now.
Great, thank you, Mark. Most of you are familiar with Visual Studio as an IDE. It is a mature product with rich set of features. But today in our session, we will go behind the scene and look at how Visual Studio developers build Visual Studio itself. Before I jump into that, I want to highlight a few aspects of Visual Studio that brings challenges for its engineering system. Visual Studio has a very large code base that is developed over 25 years, and it has it includes its core components like shell, editor, debugger, the client and UI. It also supports multiple languages, including Python, C++, and C#. And another trick that comes in for its engineering system was that it also serves as a vehicle to serve different technology constructs and support their IDE features as it ships. Next slide, Mark. Around the same time when Satya became the CEO, we started with the effort of revamping our engineering system. We started with two goals, faster shipping cadence and as well as cloud first. Why we needed faster shipping was that we realized that we need to respond to the needs of our customers, which were moving fast as the technology was rapidly changing. So we felt like they were tied to our shipping schedule, and we were not able to deliver constructs and IDE features to them fast enough. That was the first goal we started with. But around the same time, we realized that it will be a good time for us to move to a cloud-first engineering system. Why? Because we wanted to leverage the scalability and the flexibility we get from the cloud to effectively control our cost. Otherwise, we were tied with an on-prem infrastructure which had dev and test labs. So we started with these two goals and aligned it with our developer productivity goal, which was always the highlight for us. Next. So before we jump into what the new engineering system looks like, let's learn from Mark, what were the challenges in the previous engineering system that was on-prem?
Sure, so let's talk about what it used to be like. So the first thing you have to do is get source code onto your machine, obviously. But we had a TFS repo, which was, by the time you downloaded the files onto your machine, it was about 255 gigabytes. So you really didn't want to download all of that onto your machine. So you would just download the partitions that you needed to change code in, and you would just build those partitions.
So what is a partial build?
Yeah, so what we did is we split the code up into multiple chunks. So we'd have a chunk for VB, a chunk for C#, and we actually checked in binaries from previous builds so that we could build one of those chunks independently so developers could actually get work done on their machine.
Great. So let's say, Mark, I'm a developer in that engineering system. I have enlisted this partial partition, and then I have figured out which partition I have to go to, build it. So I want to test my changes once I make them.
Yeah, so the first thing you want to do is test those changes locally. And you could just sort of build your code changes, take those binaries, and copy them over an existing version of Visual Studio. But we didn't support side-by-side back then. So you would typically have a second dev machine with Visual Studio installed on it, which you would use as a test machine, and you would copy your binaries across to that machine.
Okay, so that means as a developer, I have to maintain two machines, one a developer machine and then a test machine to make my changes.
Yep.
Okay, so let's say I have tested locally. What about checking in?
So you would submit your changes to a team validation server, and because our build took so long, we used to have sort of per team servers, which would just build those partitions that team most frequently made changes in, and maybe it would run a few tests. And then if you were successful, it would check those changes into TFS.
Okay, so let's say I have submitted it to this validation server, and I'm ready to check in, and I have checked it in. Are my changes available in Visual Studio now?
They're in the branch, and they would be picked up by the nightly build. And the nightly build would take about 8 hours to run if there wasn't any build breaks.
How long this nightly build takes? Like 8 hours?
Yep.
Wow. Okay. So what happens if a build break occurs?
Yeah, so we actually had dedicated engineers, BFDs, build facilitated devs, and what they would do is they would analyze the build breaks, and then they would assign issues for developers to sort of fix as fast as possible to unblock the branch.
Okay, great. So let's say my nightly build passes, and now is it ready for me to test out in the Visual Studio?
Yeah, but what would happen after the nightly build finished is it would trigger a set of tests. So we would have build verification tests. And if one of those broke, then an issue would be assigned to you. And then, over the next several weeks, scheduled test runs would be kicked off. And again, that could find a bug in your code, and you could be assigned an issue to fix.
Okay, that's interesting. So you're telling me that I have checked it in, there was a nightly build. Now, after a few weeks, there will be tests that will be run, and I will know if I have introduced a bug.
Yeah, and typically developers had a backlog of bugs to go fix on features that they finished working with weeks ago. And we actually had this thing called bug jail, which was if a developer had too many bugs, they had to stop working on their new features and go fix bugs on the old features.
Okay, so it seems a little challenging that I have testing so much distributed and has a lot of latency. How do you keep these tests passing all the time?
Yeah, so actually it was very difficult to keep the tests running. This latency with both the build and the tests caused real problems. And we even had this thing called test analysis, where because test runs, rarely passed, an engineer would analyze the results from a test run. They'd work out which bugs were going to, be ship blocking, which bugs we'd actually seen before and we'd already filed an issue for, the duplicates, and which were just flaky tests and the tests needed to be fixed.
Okay, so let's assume that was my lucky day, maybe lucky weeks, because it takes weeks. But I was able to build it, test it, and everything looks good. So now, what was the story about dog fooding?
Yeah, so dog fooding is basically Visual Studio developers using the Visual Studio product to develop and build their code so that we could find issues before customers did.
Okay, so what about customer feedback?
We would generally do an RC, 2 RCs, release candidates, about 4 months apart before we released the product. And that's where we got the majority of our customer feedback.
Okay, so let's say we received customer feedback, we are done with the dog fooding, I'm ready to ship. What the release looks like?
Yeah, so then we have to do our final build. So we have to not only build the product, we also have to build it for all of the languages, we have to sign it, and we have to upload it to the Microsoft Download Center.
Okay, so it looks like a very lengthy process. So how long was this release taking?
Well, it could take as much as 3 weeks in the worst case.
What? After I have done everything and I'm ready to give it to my customers, I have to wait extra 3 weeks?
Yeah. So the problem here was that we had everything in the same repo. We had a big Mondo repo. So we had Visual Studio, we had .NET, they're all checked in the same repo. So we actually had to build .NET and Visual Studio together, then take the .NET bits, and we would check those into Windows, and we'd do a Windows build, so that we could send that off to the Windows packaging lab so that they could get official signed bits, which we could install on Windows. We then take those, check them back into the Visual Studio build, rebuild Visual Studio all over again, localize it, sign it, and then send it to the Download Center. So with, 6 builds, 4 different build labs, multiple handoffs, it can take 3 weeks to get through that process.
Okay, it seems like a very coupled and a lengthy process. So how often were you shipping Visual Studio?
So at that time, we were shipping about one release every 2 years, and then we would do updates about 4 months apart.
Okay, cool. So now that I understand what the background and the challenges of the old engineering system was, how about, Mark, we talk about starting from the enlistment, how things improved?
Okay, so the first problem that we had to solve was that monorepo, that 255 gigabytes, because that was causing us a lot of problem. So what we wanted to do was take that and shrink it down to a 1 gigabyte Git repo.
1 gigabyte, 255 to 1 gigabyte.
Yep.
How would you do that?
Well, we did that through componentization. So we looked for areas of the code which were decoupled enough that we could take them out of the monorepo and put them in their own repo. And then most of those would have their own Git repo. They would build and test in Azure DevOps and then insert back into the Visual Studio repo. For a few larger components like .NET, they had their own dedicated build system. And then all of those binaries that we had, we sort of had to suck those out of the repo because Git doesn't really like binaries. And the process then was each of these components would do an insertion into the VS repo, but all they were really inserting was a package ID. So we used NuGet packages mostly, and we could just take a package reference to that in the code, and then we would update the NuGet central package versioning version number during that insertion. And then we also have, especially for Visual Studio, we have setup packages, which is where the Visual Studio installer can consume those packages directly. But again, all you're checking in to the Visual Studio code base is just a reference to that package.
Okay, great. So it was an intelligent use of NuGet and central packaging version. Great. So now that I have a smaller repo to enlist, what about the build? How will you improve build for me?
Yeah, so it's still, there's still a lot of source code there. It still took a lot of time to build that. So what we did is something that a number of companies with large repos have done, and Microsoft has lots of large repos. So Microsoft invested in a distributed build system, which we call Cloud Build. And the way that works is Cloud Build would do the NuGet restore to download all of the packages, and then would call MS Build to generate a build graph. So this is the order in which the projects would be built. And then those individual projects are sent off to be built on VMs independently. So we would build the project, and we would save the outputs of that project and put it into a cache. And then the next project in the chain would download the outputs from the previous project, and then we'd sort of traverse the graph that way.
So what is this hash match that you have mentioned?
Oh, yeah. So at the beginning of that process, we calculate the input hash of a project. And so that's all of the files that it's consuming. If that input hash already has a match in the cache, we don't even need to build the project. We can download the outputs from a previous build of the project. So we can have subsequent builds of the Visual Studio repo. They don't build every project. They only build the ones which are impacted by the commits that people check in.
Okay, great. So how about, Mark, at this point, why don't you show us what changes, what does it look like for a developer to make changes in Visual Studio and build it on their machine?
Yeah. So I'll mention just before I do that we also use that cache on the developer desktop. So we can download pre-built binaries onto the developer desktop. So let me go grab a dev box.
Okay, while Mark is setting up and connecting to his DevBox, let me tell you what DevBox is. DevBox is a pre-configured developer machine in Azure. All Visual Studio can use this machine for their development. It comes with their repo enlisted to the latest check-in commit. And then we also have two versions of Visual Studio side-by-side installed, one for their development and one for testing. They have the dog fooding version installed for their development, and then the latest commit, Visual Studio, is also installed on it as a main version for their testing. So, Mark, are you ready to show us?
Yeah, so this is the DevBox interface and where I would create a new DevBox. And as you see, I've got 4 of them hanging out already, so I'm logged into one of them. And so we want to make a change to Visual Studio. So let's change the About box. And Okay.
So which project are you going to?
Yeah, so this is UI internal, which I know happens to contain the about box, and there's,
Okay.
I don't know, like 9,000 projects or something that we have. Oh, see, I've practiced this demo before, so Visual Studio has remembered what saved me a bit of typing. But anyway, I have changed the about box of Visual Studio to be the Ignite edition.
Okay, great. Sounds good. Now let's build it. But before you build it, can you show us how Project Cache works on the developer machine? And
Yeah.
how we make use of pre-built binaries?
So what I'm going to do then is build this from the desktop. And I'm going to do this from the desktop because you'll see the logging of that downloading of the cache.
Okay, great.
Okay, so let me kick off the build. We're building the UI internal project. And the first thing you'll see here is it basically generates that graph. And it says that it's found 264 nodes in the graph. So those are MS build projects or projects building for different architectures. And then you can see that it says Project Cache plugin. So we wrote a plugin for MS Build. And what this does is at the beginning of a project build, it calculates that input hash. And then it goes looks in the cloud build cache to see if one of those, if that hash already exists. And then, if it does exist, it's going to download the files instead. So what you should see in a few seconds, taking longer than normal because it's a live demo, and that's what happens in live demos, is it will, it's working, yay. It will get a cache hit, and you can see that most of the projects here, it's getting cache hits. And now it's actually going off and building the UI internal project that we changed. So while it goes ahead and does that, let me open Visual Studio main.
What is Visual Studio main?
Oh, right, yeah. So as Fatima mentioned earlier, we have into preview, which is our sort of internal dog food version, which is the one I was editing the code with. But we also have installed on the same machine main. So main is our central trunk branch. This is where developers do most of their work. So they're going to create a Git topic branch off main, do their development, and then submit a PR back into main. So this version of Visual Studio exactly matches the commit of the repo that I was enlisted in when I picked up my dev box.
Can you show? Did you show us the about box?
I'm
how it
about to do that.
Okay,
so there we
great.
go. So here's the about box, and as you can see, this is perfectly normal. So I'm going to close this now. We can see that it's finished building. It only actually needed to build one project, which is great. So that saved us a lot of time there. And so what I'm going to do now is copy the files across. And like any developer, I prepared a script to do this for me, so I don't need to do the typing.
How are you copying Visual Studio files? Because they are signed.
Yeah. So that main version is a test signed version, and then we basically do some registering so that we're allowed to modify those files on the machine, and it will still load.
Okay.
So what it's doing here is it's just a copy. It's copying a file, this resources file, which contains the about box resources, from our binaries directory from our build, and it's copying it into the Visual Studio program files directory, and this one's our main version. So that's all this script does, nothing fancy. And now, all going well, I will open Visual Studio.
Ooh,
I will go help. I will go about. And we get the Ignite edition. The demo worked.
Awesome. That's how simple it is to make a change in Visual Studio now. Okay, cool. What about checking it in?
Yeah. So like I said, at this point, I'd add my commit. I would push the repo, so we do a good git push. I would go to Azure DevOps, and I would create a pull request. And of course, I'm not going to do that live. I prepared one earlier. But Fatima, why don't you walk us through what the developer experience is like in Azure DevOps now with a pull request?
Yeah, let's chat.
Whilst Fatima's getting set up, one of the great things now as a developer is that I don't check in and then a whole bunch of builds and tests and everything like kick off afterwards. As I add commits to my PR, those commits, every single commit that I push to my PR is going to be built, tests are going to be run against it, and then only if once all of those passed will it be checked in.
That's me. Yeah, that's great. So, yeah.
Yep.
We're ready to show you how Mark, your changes look like in Azure DevOps. So let me click on this file, and you see that this is the line that you changed in Azure DevOps. And then let me go back to your PR and show you that there are a few policies that we apply, like few runs that we run on your PR. First thing is to do the cloud build, which is mandatory to make sure that that passes. And then we run a few tests for your PR.
And what kind of tests are we running here?
We are running both integration tests and performance tests. Just to give you an idea what integration tests are, they are end-to-end tests for your feature. In integration test, one interesting thing that we have adopted is instead of running all the tests all the time on all your PRs, we have introduced a concept of defining test filters. So every Visual Studio team who owns a feature, they are responsible for the quality of their feature. So they author their own test and define filters on which areas, if they are changed, which test should be triggered. So we have these filters behind the scenes, and that's how they actually run and trigger them automatically.
So I noticed that like the perf test there, it says request next to them.
Oh, yeah. So actually, there's another point I wanted to mention. Then in integration tests and perf tests, both are blocking for your PR, but integration tests are automatically triggered. Whereas perf tests, we don't trigger them automatically because we run each test multiple iterations, and they are expensive to run. So we want users to make or the developers to make a decision when they are ready to check in to trigger them only once in their PR lifecycle. So this saves us a lot of cost.
That's great. And where are all of these tests running?
So all of these tests are running in Azure. Let me step back and show you what our test workflow looks like. So once you have triggered the PR and we had the PR build, the next thing you see is behind the scene, we have different Azure functions implemented and orchestrating all the test pipeline workflow. We have create pipeline Azure function, which actually filters and select the pipelines that are relevant to your PR changes and trigger that test pipeline. In the test pipeline, you see another deploy machine Azure function. We have a whole VM orchestration system that relies on Azure DevOps, Azure Dev Test Lab that creates the VM. And each VM is hosting a base image of the VM.
And what's in the base image?
Oh, so, base image is hosting like latest image of OS that Visual Studio supports, and the latest build of Visual Studio that was just already checked in before your PR. And why we do that? Because we don't want to install Visual Studio from scratch and waste time on it and cost. We actually do a build-to-build upgrade, so apply your PR changes as an upgrade on top of the Visual Studio base image, and then we deploy test on top of it. And once we have the test deployed, we run it. We have another function, Azure function that monitors the pipeline, and once the tests are available, we report it back to the PR.
Great. So what does this look like in the PR then?
Yeah, let me step back to my PR. And if you see here and scroll down, you will see a comment that says there are required tests running. And if I expand this, you see two pipelines triggered. And if I click this one, you will see that you have your these pipelines selected, and there are a bunch of tests within this pipeline which were run, and they are all passing for you.
Okay, so that's cool. So I can see my tests in Azure DevOps. I can look at the test results. I can dig into the logs and that kind of thing. So how, with all these teams developing tests, how do I know that like I'm not going to be blocked by some flaky, unreliable test?
That's a good point, Mark. That was one of the things that teams also shared their concerns. So what we have done is we have defined different test categorizations. So we have required tests, optional tests, and experimental tests. So whenever a developer is working on their feature, they add their test in the share pipeline as an experimental test. That means these tests will not block your PR, but they will be collecting data against it. And once they are confident with their results and they want to make it a blocking test, they add it as an optional test. And the optional test is when we collect data and make sure that the test is reliable before it can be part of PR blocking. Because if we block the PR, it is a lot of like resource wastage and developer productivity impact. So we, after optional tests have reached their reliability, we go, they can be promoted to the required test.
That's great. So I'm going to submit my PR. A bunch of reliable tests are going to be run before I check in. Do we still do scheduled test runs?
Yeah, no, we don't do any scheduled test run for the shared pipeline, but we do support our developers to have test pipelines implemented. They can run them when they are developing new features as they like. So there are no scheduled tests for the main PR's workflow, no.
Great, great. So you've described how our integration tests work. Do our performance tests work in a similar way?
Yeah, performance tests work in the similar way, and we have the same workflow. But with the performance tests, when we moved from on-prem to the cloud, we were challenged with the noise cancellation problem. The problem was on-prem, we had a controlled environment, dedicated hardware, and we were running our test on it, and we were having minimum noise in it. But when we moved it to the cloud, these tests were running on VMs, and each VM can be running, like each machine can have multiple VMs and running multiple services. So we had the problem of noise being introduced in our results.
Oh, so how did we solve that problem?
So we actually moved away from the time-based metrics to a consumption metrics. We relied on the VM resources that Visual Studio uses versus the time it takes. So we relied on CPU, memory, and other resources in the VM to analyze our performance test results. But yeah.
Yeah. So how do I look at the test results? How do I analyze those performance results?
Yeah, sure. For that, we have implemented another tool within Azure DevOps. And let me show you. This is performance integration tool. Impact tool, PIT. And then the workflow of the test pipeline remains the same. Only thing that has changed for performance tests is that in the finalization state, we actually collect different counter data. And then that counter data is stored behind the scene. And then those test results and counter data are analyzed against Visual Studio baseline performance. And then results are again stored back in the storage. And then once those results are available, you can trigger a performance impact tool from your PR to look at the results.
Great. So can we see that? Can we see the tool? Can we see what it looks like?
Sure. Let me step back to your PR. And if I scroll down in your PR, you can see that there are different performance tests that are triggered. Here you go. And you see that there is a link to the PIT where you can open them and view them. So let me go to your performance test results. And as Mark, you can see you have no regression in your PR.
Woohoo!
Obviously, we just changed a single text in the about box. But I think more interesting example will be looking at another PR, which has some regression being introduced. So if you have a regression, this is how your input will look like. There's a trend line. This trend line is actually the counter data that we have collected against a test run. And if you go across this trend line, you'll see this green mark. This is actually the baseline for our performance.
Right. So what is the baseline in this case?
Oh, so baseline is actually the performance of Visual Studio that is up to par for last check-in before your PR changes came in. So now that your PR changes are in, you can see when you trigger the run, these are the regressions that happen, and they are marked as these points on this trend line. And if I go up, you can also see that this is not the only counter data we collected. We collected almost 440 counter data, and out of those, only one regressed on a test run that we did for performance testing.
So this is great. So we now have our builds running in the cloud. We have our integration tests running in a cloud. We even have our performance tests running in the cloud. So Fatima, how has this changed our ability to get technology to customers in a more timely fashion?
Great. Let me step back and tell you how we are doing on our releases now. We are shipping every week. We have internal dog fooding builds available daily. That means even every PR build that you do, you can install it and test it. For external dog fooding, we have preview builds that we ship near the major release every week and monthly also. And then we have major release that we are shipping regularly. If I look at the data, let me show you a little more of how many Visual Studio releases we have actually released publicly in the last couple of months or so. You can see that we are shipping every week, and even on a single day, we can be upgrading multiple versions of Visual Studio because we want to support our customers who are moving forward on the technology at their own pace. So all of this has been possible by scalability and the flexibility that cloud brought for us, and also all the build and distributed build system and all the other initiatives that we took. And this was all the things that we also relied on, which is like Microsoft services, Azure DevOps, Azure Azure DevOps extension. So all the things that we have used to achieve this. I hope that it was a good learning experience for you to see how we have evolved our infrastructure from on-prem to a cloud, and can use some of these technologies when you go back.
Great. Well, thank you, Fatima. And we're open for questions.
Thank you.
Cool. Let's go ahead and bring up that slide with the QR code to get people a place to get their questions. While we're doing that, we'll go ahead and look at some of the questions here. Let's scroll down just a smidge here, Molly. Here we go. Here's a great question saying, if the nightly build took 8 hours, how many logs were generated? And did people actually go through those logs?
Gigabytes. many gigabytes of logs were generated. I mean, the drops from those builds are like, I don't know, 100, 200 gigabytes or something, and
Seriously?
we save off all the logs and everything. But most of the time, we don't look at the logs, and one of the lessons that we learned was basically we don't ignore warnings. So we switch all of our warnings to be errors, and because having a product with thousands of warnings in it, no one's ever going to look at those. So we turned all of the warnings to errors, and we went through a big process of either fixing or suppressing the warnings that didn't make sense. And now if a new warning is introduced, it breaks the build in the PR, and the developer decides, is that useful to me, or is this something I need to suppress?
I got you. So a warning is really just you're never going to look at it. So it's either it's a to-do, it needs to be done, or it means nothing.
Yep.
There's no middle ground.
Yep.
Interesting. All right, that's a good one here. Here's an interesting question from Eric saying that the test virtual machine looks like, from watching the session here, a single image of the latest operating system. Do you test across other versions of other operating systems? Do you have an array of different versions of Windows?
Yeah, we do. So during the PR tests, we will test sort of like the latest version of the operating system. But we do have other test runs which sort of do app compatibility across different operating systems.
Okay, so then main gets a full matrix of tests, while every PR is more of a smoke test, and then once that PR gets merged into main, it's more formal?
Yeah.
Okay,
And
cool.
it's always a balance with us about like what do you do like the moment the developer checks in, and you want to do as much as possible there, and then what do you do afterwards? And the stuff that you do afterwards is the stuff that like hardly ever breaks, because otherwise it becomes too disruptive.
A reminder, of course, for friends in the room, you can scan that QR code, and that'll put those up on the main screen here. So questions from the audience we can put right here as well. What are we having here from Pedro? Is PIT open for public?
Performance impact tool. No,
Performance
it's not
impact tool.
open for public. So question, maybe you want to say the question. Is it open for public? That's the question, but no, it's not. And we are looking into like what we can do either internally, making it easier to put it in a product or whatever. We haven't made any decision. It's just a plug, Azure DevOps extension.
Well, but that brings up a really interesting, larger kind of philosophical question. How much stuff are you showing that is stock, like you're using Azure DevOps?
Yeah.
And how much it is highly customized, because what you're doing is highly customized? And then how do you decide what you want to make public versus, you don't really want that?
Yeah.
Yeah.
Go ahead.
Yeah, we have a principle as a team, which is basically to write as little code as possible. So we always try and use shipping products or take the technology that we're using into shipping products. But there are cases where we have to sort of customize for our environment and do special things.
Yeah, and also one thing when we were analyzing PIT, we just looked at it. Okay, how can we make it more like compatible with different technologies? We haven't looked into that, so I think that will be too early to say it could be public.
I think it is a nice compliment, though, to the team that even though you're writing these internal tools, that people outside want them. So you may end up becoming a product org, another kind of product org, where you're going to create tools to help people build other things that are giant like this. Question from Olga saying, is this plugin available on GitHub? I'm not sure which plugin that they're referring to.
Yeah, so it could be there was a couple. There's Pit, which is a Azure DevOps extension, and then we have the Project Cache, which is an MS Build extension. Again, they're not publicly available.
They could be, right?
I think we've got links for like BuildXL, which is kind of the open source version of a lot of the cloud build type technologies. So people can take a look at that.
I noticed a question about dog fooding Visual Studio and what our experience was like. I would say that maybe 10 years ago, it was quite painful, and I kind of had fear of Visual Studio, but then something happened where suddenly they could be side by side, and it was very friendly, and now I have like 3 versions installed.
Yep.
What happened? When about did we be able to have multiple versions of VS installed side by side? And did that make dog fooding and testing branches easier?
Yeah, so that was like a rewrite of the Visual Studio installer to sort of break it up into components and support side by side. So there was a lot of work involved in doing that. And at the end of that, we actually had this ability to install multiple versions of Visual Studio side by side, which was not only important for us as developers, but it's also important for customers, because when we wanted to like send previews out like every week, and if we're going to do that, then we needed to lower the friction for customers to consume those previews. And it was just too expensive to take a chance on a version of Visual Studio on your main dev machine. So you'd have to create a VM or grab a second machine to test it out. And that was too much friction. So that's why we put the effort into enable side by side.
And I remember that the Visual Studio installer has like feeds now. So most people get the public feed, right? But when you do a PR and you say that you can install that, are you installing it from the Visual Studio installer?
We are installing it from the Visual Studio installer, yes.
Yeah, so you don't just like copy Visual Studio into a folder. You actually run through the install process, even for a pull request.
Yeah. And for those dog food versions, you'll actually get a toast, which will encourage you to, you get like a toast every day, but encourage you to upgrade to this day's version of dog food.
Lovely compliment here from Ivan. Just nice to throw in a compliment how much they enjoy the Community Edition as a small business, the ability to have a pro version of Visual Studio for open source small businesses, schools, and nonprofits like that. So kudos to Ivan for that very kind statement. Let's see what else we got here in our questions. This looks like an internal one here. There's some code names here. Maybe you can help us understand that. So, the question is asking, has the Visual Studio team migrated off of a thing called Mad Dog?
Yes.
What is Mad Dog? Is that something?
Mad Dog was an old orchestration system for running the tests. And yes, we have migrated off of Mad Dog to ADO. Yeah.
And then what we're showing right here is live. That's real. That's how were those fake web pages, or was that actually?
No,
that was all live.
Yeah, we had to get permission for those kind of
and the other thing about ADO, though, I mean, we do report all of our tests back to ADO, so everything shows up in Azure DevOps.
Yeah.
Interesting philosophical question here from Nadia saying, well, how do these changes impact a general developer? I'm getting updates faster.
This is a very good question. Previously, yes, when we were excited, we started with this whole effort of revamping the infrastructure. We were deploying as fast as we can. But then we realized that no, with our developer, with the major releases, we do kind of tackle it in a way that we have enough time to validate. We have a validation process before we deploy, and also make sure that it's not on critical dates. Yeah, we do follow that.
Yeah, and then for me as a downstream, I'm downstream of y'all. I have both the int or the internal preview version installed. I've got the public preview installed, and I've got the actual released version installed. Just having side by side, I don't have that sense of fear. I'm not burning VMs just because I want to run Visual Studio.
Yep.
And
So,
then,
so I was going to say, like, as an individual sort of IC developer, checking in was scary before because you knew that you hadn't done enough validation, right? And there was a chance you would break the build, there was a chance you'd break the tests. And now, like, checking in is fairly safe activity. The pull request is going to do as much validation as it can, and your chances of, checking in something bad are significantly reduced. And you don't need to do all of that validation on your local machine because, that's going to happen in the cloud anyway.
that's awesome. Question here from Jeff wants to know how you set up those filters. When you had the test filters, are you tagging each PR? How did you group your tests?
So we have test filters based on the code area, and that's how we categorize that this code area, these are the test pipeline that are relevant. So that's how we are defining it. That's done through Azure DevOps.
Okay. And then Alon is asking, what's the next big challenge? You went from 255 gigs to 1. What's next? What's the big challenge?
Next challenge is to make everything more and more faster, because if it takes, let's say, 20 minutes for build, maybe go to 15, maybe go to 10. So making more and more faster. And when I say build, it means in the cloud. And similarly for running the test, as fast as I can create machines on the Azure, as fast as I can run tests on those machines. So performance is the next big challenge.
Performance as a feature. We did answer that question from Jeff. Let's see what else we've got here. Going. Interesting. This is more philosophical. This is probably outside of our scope here, but the question is, will we always have versions, or will there just be one version of Visual Studio? This person says they've got VS 19 and VS 2022 and da-da-da-da. I think versions are kind of required. There's no way to have one version to rule them all.
Yeah, so we do have previous versions of Visual Studio, and when I showed that, actually I can't bring it up, but release page, you can see that there were multiple versions of Visual Studio that were shipped. And sometimes we have security fixes, and they go in the same day.
Actually, that's a great point. So you're building, the head. In this case here, you added the about box to main, but you still have all these other versions that are still building, right? So people are checking into pull requests on 19, which is building and being tested and running through the whole process as well.
Yeah, all of our infrastructure is on Azure DevOps. We don't have any are there any version though? I think the last one expired, like the servicing life has expired. So we have everything on Azure DevOps now as an infrastructure. Remind me, Mark, if there is any we have on older system.
Yeah, we might have one from like 59.
59 has service.
Is that done?
Yeah.
Yay.
Okay.
So you're saying that there's a matrix of all the versions of Visual Studio and all the operating systems, and everything is now entirely in Azure DevOps.
Yes.
Yeah, but I think the thing, going back to this question, for customers, not every customer can move to the latest version like immediately, right?
Yeah.
So we have to be able to provide security fixes for those customers who want to stay with an older version, and then they will upgrade on their own cadence.
Yeah.
Very cool. And then just a personal question, do you all give a lot of technical talks at Ignite and Build and stuff? You do a lot of talks like this?
No, never.
No, this is my first one, like this.
All right. So I want you all to appreciate that. I want you all to know that, and I want you to know that I called Fatima and Mark, and I said, "You're doing a talk at Ignite," and they're like, "We are." So they were we call it being voluntold, and I thought they did a great job. First technical talk, and they crushed it. Let's give them a big hand.
Thank you.
If you want to see content like this, tell us on Twitter. Put it in the evaluations. I thought they did a great job. Give them the evaluations. They will read them. They will see them. Be nice. And then put them on Twitter. We're going to take a short break, and then we're going to come back with Safia Abdullah and Stefan Halter, and they're going to be talking about minimal APIs again. Lots of code, lots of deep dives. Take a quick break. Call your friends. Get them back in here at Ignite. Thanks so much.
Thank you.
Thank you.